Alright, example number 3. We're going to solve another system. So part 1, solve the system, then classify. So you always have to have an answer if I say solve the system, whether it be the coordinate 2 comma 5 or infinitely many solutions or no solution. So let's see what this comes out to be. And you could probably guess, but think about this for a second. So if we wanted to graph this, then graph this. Couple ways to graph. You can put in slope-intercept form. Right now, actually, that would be easiest in this case. Or you could do your intercepts. Plug in 0 for x, get y. Plug in 0 for y, get x. So let's change the form on this. Y is equal to. So just subtract 2x from this side. Put it over here. So negative 2x plus 4. This one right here, minus 2x here, minus 2x here. This would be y equals negative 2x plus 1. Look at those two equations for a second. Notice that they have the same slope, but different y-intercepts. So if we graph that real quick, what would happen here? These two lines are parallel because they have the same slope, negative 2. So here's the plus 1, down 2 over 1. Here's the 1 line. Here's the plus 4, there's the 1 y-intercept, and then down 2 over 1. So there's your slope. So these two lines are parallel, which means they never touch. Well, guess what? If two lines never touch, they never have one coordinate in common, or any coordinates in common for that matter. So if they don't have anything in common, guess what? There's no coordinate that satisfies both of these equations at the same time. There's no coordinate that makes both of these true at the same time, which means you have to write down the words no solution. So if I say solve the system and they're parallel, that means, oh, there's no solution here. You have to write that. If you don't, I can't assume that you know it. Next it says then classify. So is it consistent, independent, consistent, dependent, or inconsistent? Well, the only one that fits is inconsistent. Inconsistent means there are no solutions for this whole system. So no solution, and part 2 is inconsistent. Okay? So know your vocab. Inconsistent, no solution. Alright, so we went over one that you had a solution. So let's actually take a couple notes. So whenever you have a graph, and let's just draw one line. There's one line, and here's another line. What happened to these two lines? They intersected at one point. Well, that point, x comma y, you would say, oh, x comma y, whatever that is the solution. Right? That's case number 1. Case number 2, what if you had, there's your x and y axis, and you had you drew one line, you found your intercept, whatever, you found this, and then you found the intercepts again, and they were on the same exact line. So really, you don't have to draw it again, but I think of it that they're on top of each other, which is not true at all. It's just easy to think, oh, this line is on top of this line, which means they intersect at every point, right? So that in my mind, this is how I rationalize my mind. And so therefore, oh, they're intersecting everywhere, which means there are how many solutions? There are infinitely many solutions, okay? If it's the same exact line. Last, so part 3, I'm going to close this off weird, I know. Part 3 is if you have one line and then another line, and these two lines are parallel, which means if I said what is the solution to the system, you would say there is no solution. I'll give you a little shortcut for that. If you see a circle with a bar through it, just do it one time. Circle with a bar, that means no solution. Okay, I'd accept that if you wrote that. Alright, so those are 3 things. If I said what is solve the system, you would write one of these 3 things. This is a solution, there's infinitely many solutions, there's no solution. But if I said classify, this right here is consistent, and Is it dependent or independent? Well, when it's one solution, it is independent. If I said classify, you would write this. What if you had this right here if I said classify? It would still be consistent, because consistent means there's at least one solution. And in this case, these would be dependent. And lastly, if I say classify this system, not solve it, but classify it, you would say it is inconsistent. Is it A or E? Yeah, that looks weird. I'm a math teacher, not English. So, inconsistent. Alright? Got it? That's how you classify.